Okay, in this video I want to talk about calculating the force of friction if you know or have estimated your coefficient of friction. The equation for the force of friction is that the force of friction equals the coefficient of friction times the normal force. If you've done an experiment to measure your coefficient of friction, great. If not, use something small like 0.1. So I'll just take a guess. We're using a coefficient of friction of 0.1. Coefficients are unit-free numbers. There are not a lot of those in physics, so you don't need a unit for the coefficient of friction. If you look at the force of friction equation, you'll see that a force, which is measured in newtons, is equal to something times another force, which is also measured in newtons. So that shouldn't have a unit. Basically, it's a ratio. So I need to find the normal force first in order to calculate the force of friction. Easiest one is if I just have weight, which is equal to mg, and normal force, and because this isn't accelerating up or down, these two are equal, so my normal force is equal to mg, and my force of friction is going to equal the coefficient times mg.
Everybody make your way down to the Beit Midrash for the debate Midrash. Thank you.
If I'm on a ramp, I'll have weight, which is mg. This will be at an angle, and I'll want to divide my weight into two components. The into the hill component is going to be mg cosine the angle of the ramp, and that is equal to the normal force. So here the normal force equals mg cosine theta, and the frictional force is just mu mg cosine theta. The frictional force is always the coefficient of friction times the normal force. For a loop, if I've got a situation like the bottom of the loop, this is the bottom of the loop or a scoop, mg is a force, and I also have a big normal force. The equation to get the normal force is just normal force minus mg equals mv squared over r, where v is the velocity at that point, and r is the radius of this loop. That's the centripetal acceleration, v squared over r. So normal force is going to be equal to m times v squared over r plus g, and the force of friction is mu times that. On the side, the normal force just is the centripetal acceleration times the mass, because that's the only centripetally directing force I have. So the frictional force is going to be mu mv squared over r. At the top, both gravity, the force of gravity, and the normal force combine to make the force in the centripetal direction. So I have normal force plus the force of gravity equals mv squared over r. I do some math there, and I'll get normal force equaling m times v squared over r minus g. If I multiply that by the coefficient of friction, I'll get the frictional force. Friction is always against the motion and parallel to the track. So if my thing's going around a loop in this direction, like swooping around, friction will be backwards, friction will be down, friction will be left. Last but not least, on the top of a hill, again, weight goes down. In this case, normal force is going to go up. The center pointing direction is the center of this circle. So gravity is the positive one here. Normal force is negative. That's going to equal the mass times the centripetal acceleration. If I solve this for the normal force, I get mg minus m times g minus v squared over r is equal to my normal force. I'm going to multiply that by the coefficient of friction to get the force of friction. So basically, if you know how to get the normal force, it's pretty easy to get the force of friction in a nice math way. All you have to do is either estimate a coefficient of friction or do a little experiment to find a good value for the coefficient of friction. Or you can look up what the coefficient of friction is. Or you can ask somebody who did it last year. They might have done an experiment. That's how to do it.